I sent it to the, what's it called? To the flash. It's on the flash. So you can check it out. GIS tutorial. We have GIS tutorial 1, 2. The first one is the basics. Second one is the spatial analysis and I think advanced, whatever. Advanced workbook, yeah. This is it. The basic workbook, the spatial analysis, and the advanced workbook, whatever. So I have it in the flash. I sent it already. So we all know how to open and save a map document. Can we do all this? Hello, Benga. Topography, yeah. Okay. So, can someone explain what digital topo is all about? A digital topographical map, what's it all about? Yeah. The 2D features within the environment with respect to your height, that's all. And let's assume you got it right. Let's assume you got a project and the deadline is 24 hours. And you want to carry out a digital topographical map of OAU. You are given as a task to do, and you are asked to submit in less than maybe 3 hours or 4 hours. How do you automate these tasks? It's very simple. I told you last time that you can make use of data prepared by OpenStreetMap, right? And then how can you do that? You can either download straight away from your BBE bike extract or using your GeoFabrics data. Okay. I said you can either make use of your BBE bike extract, or you can use your GeoFabrics data. If I make use of my GeoFabrics data, it's going to take much time because the amount of data to download for the entire Nigeria is too big. So I'm going to use BB bike extract. So let me quickly search that. Yep. Are we on the same page? Awesome. So we want to prepare a digital topographical map of OAU. Now, I want to download the data sets needed for me to prepare this map. Now, I click on BB extract, open whatever, OpenStreetMap. So, the first thing to do here is you have to select the format you want to download, and we all know that extract, yeah. And we all know that it's Esri shapefile, right? We want it in shapefile, so you can just click on Esri shapefile, and then the area to extract, just type OAU, and then your email address to send the data to. You can just select. Mine is Balaji Samuel 20, blah blah blah. So, are we together? BB extract. Okay, don't let me make a rush. Okay. Now, we zoom into Ife, and then you've seen it right. Now, then select now. Now move the map to your desired location. So I'm at my desired location now. Ife. Out together. Don't zoom in too much, so that it can capture your study area very well. Are we together? Are we all together? So you click here. I think I'm still okay with this. Are we together? Where do you get it wrong? Let me know. Yeah? Now, huh? Query formulation, yeah. So you click on your selection. For you to perform your query, you click on your selection. We have three methods of querying: by graphics, by attributes, by location. In this case, can someone tell me which one to make use of? No. By location. There's a boundary. Your attributes work with respect to your database, like your attribute table. Select where Nigeria is Osun State. Are we together now? Like the coding, yeah, you're right, sir. Now, select by location is what you're going to use here. So select from buildings where my source layer is OAU boundary. And then the special selection method will be are completely within the source feature layer. Are we together? We have two data, the building and the boundary. Your selection by location is that your system will you tell him, I want you to select every building within this boundary. So that's the query formulation. So there are a lot of special selection methods you can make use of. Are we together? You can either use intercept, like crossing the line. We use this when we're dealing with your buffering analysis. When you want to know how many buildings are serving maybe 30 minutes driving radius, whatever, from an hospital. So we can use this type of query to determine how many buildings are satisfying a particular maybe school, hospital, or whatever. Are we together now? Yes. Yeah. So I'm going to choose are completely within, then I'm going to apply. Within the source layer. So I apply. Can you see that? It's selected. Okay, it's loading. It's selected. Are we on the same page? On the same page? Raphael? Femi? All right. So now, Aisha. So we now click on OK. Yeah, good. So we are going to create a new layer from this selected layer. How do you do that? You right click on your building, selection, and then create layer from selected features. Are we on the same page? No. Right click on the selection, on the building, selection. Are we together? Now create layer from selected features. Are we there? Second to the last. So once you do that, just click OK. We have the building's selection. Are we on the same page? Femi, what happened? Benga, Oko, Ini, Josh. Okay. Raphael, are we on the same page? All right. Ife. All these ones are gurus. Don't mind them. All these are gurus. And Kwelumi, they know it. They know it already. Don't mind them. You're lost, K. No. Can we progress? All right. So now click on this selection. Hello. Click on the selection and clear selected features. Clear the selected features. Clear it out. And then you can now remove your existing building. You are clearing the selected feature. You know, you created a layer from the selected feature. So you have to clear that selected feature. Go to your selection, then you have it active if it's been selected on your own side. Did you have it active? Hello? Clear the selected feature. Clear. Are we together? Now you can remove the building, the entire building. We are of no interest. So we are only interested in buildings within OAU. Are we together now? So instead of digitizing, for like maybe one day, we are done with this open street. Of course, accurate. Yeah. I'm still going to teach you a method for that will be artificial intelligence in GIS. We call it object detection. You can detect objects if you have the sample. You are clearing the selected features. Have you done that? Have you cleared it? Go to the. If it's not showing, that means it's done already. Are we together? Okay, right. We have to very fast. We have like 10 minutes and grace of maybe 5 minutes. So we have to very fast. We have to very fast. Now, I'm going to remove this. I don't need it. Oh. So. Alimashi to play because Amashi digital mapping. This is digital mapping. Digital topo. The topo is like you're trying to bring in the height. So maybe we'll do that next week. The contouring, yeah. We'll do that next week because time is going already. So I should zoom in, alright. Hello, well done. You can see that. So these are the footprints of all the buildings within OAU. Are we together now? Yeah. Can we import the road now? The road network. Let's bring in the road network. Roads. You said? Okay. It doesn't cover the entire OAU, right? So that means you have to re-download your data, yeah. But you can neglect that. You can do that again later. All right. Okay. The land is just based on settlement, like the extent of how man has built up buildings and whatever. Like, let me bring it in so you can see what I'm trying to say. Settlement is just like the land is not land is land or whatever. So it means these are the extent of where humans has utilized has utilized over time. Like it's just like you have like if you're on your Google Earth, there's going to be an extent of where you have your buildings. So you just trace it out that this is the extent of where humans has built up. Yeah, you won't have anything inside. Yep. I don't know why. I don't know. But basically, it's within Ife alone. I don't rely on the land use. I don't rely on it. Yeah. So that's good, sir. So you can bring in the other geographical roads. Bring in the roads. The roads. Can we drag it in? Yeah. So that's the road network. The road network. I taught you how to add your data. How you can add your data, I taught you already. So now, the operation to make use of here is clipping. Because we want to clip, you can also use your query, but I prefer using clipping. Because clipping is going to like work with respect to the outline. You can use clip for points or building because they are not intersecting the outline. Do you get my point? You can't use clip 2 for building because your building is not intersecting the outline boundary. You can only use your clip 2 for lines to polygon. You can't use polygon to polygon. You can only perform query that selects every building you have within this so region. Are you with me now? So good. So now, can we all search for clip 2? Search for, if you don't have this search, this is where it's located. It's located up here. Yeah, yep. Yep, yep. Can you see that? That's it. That's it. Can you see my mouse? That's why you have to search. So search for clip. CLIP. Then enter. Are we together? Yeah. Other rows. Because it's intersecting the outline. Your building are intersecting. You have them having their own location. You are clipping, yeah. So you search for clip. You're going to have these results. And then we have to clip two. We have one for your vector. You have one for your raster. This is vector. Your vector is represented with points, lines, and polygon. Are we together now? So your clip in this case now will be on analysis. But in case you want to know where this clip is under your toolbox, you click the third this particular two boxes, whatever. Let me click on it so that you can see what I'm trying to say. If you click on this, can you see it's located under analysis tools? Are we together? Located under analysis tools, under extract, and we have clip. Are we together? But I don't disturb myself searching for wherever it's been located. I'll just search since I know what I want to work towards. I'll just search clip. So it will bring me every clip, whatever tools they have. Search. This is up. All together now. So you can just click on that, and then the input features will be your road. All together. Your input features will be your road, and then the next one will be your polygon, your study area, which is OAU. All together. All together. All right. We want to clip. You search for the clip tools. You have this. Input features, the road, man, analysis, yep. My stem is hanging. I have to close some whatever, blah blah blah, to release some RAMs. Yep. Are we on the same page now? Hello. Your input features will be your roads. Your clip features will be somebody should just put him through. Your clip feature will be what? Boundary. OAU. Your input features will be your road. Your clip features will be your OAU boundary. Are we all together? Hello? Are we together? Your boundary. OAU boundary. Yeah. Are we together now? So you now click on OK. So it will work out straight on its own. So you can see the progress. Leave it, it's optional. Tolerance is like how close one layer over another. It's like, tolerance is like, that works when you are dealing with network analysis. Tolerance in the sense that how close is this to this? Are you with me now? So it's optional, so I don't really need it. So that's the reason why I don't use it. I don't use it. How close you want the clipping to be, but I don't always use it. Sometimes people use 0, so it's better you just leave it that way. So if I have my boundary here and the road is stopping here, the tolerance is like what's the maximum distance for it, yeah, to the boundary, you get it. So that's the tolerance, like an error to cover up. But it's very important when you're dealing with network analysis of road, because when you're trying to like check for the fastest route, you must use tolerance. Because if you say I'm stopping here and your building is here, so the tolerance must be calculated like within the radius of maybe 5 meter tolerance. So it has to catch that particular object you are tracking. So that is what tolerance is all about. So you can add other spatial data. Hello? Are we together? All right. So you can add your waterway, repeat the same procedure. You clip anything line to polygon, you clip. Polygon to polygon, you perform query. Point to polygon, query. Line to line, you clip. Line to polygon, you clip. Yep. Oh my God. This is what I'm trying to say. Right click on your road, or you can double click on this, or you right click, go to properties. Either of the two. Go to symbology, category, select by type, uncheck this, add all values. Add all values. Symbology, categories, feed values to be typed, and you uncheck these other values, and then you add all values. All values. Are we together? Add all values. Add all values. So once you do that, now you can there's something called cartography signs and symbols. You can search for that, but so once you double click on this, you can search for footpaths. Yeah. So depending on the choice of whatever, man, because our road is no. We have different type of road. We have some to the third, we have one to the tertiary, primary road. We have primary road, secondary road, tertiary road, footpaths, whatever. So that's the reason we are, man. Now you had all values. Yeah. Add all values and then click OK. You select with respect to road type. So we have footpath, path, residential, secondary service road, tertiary, trunk link, and unclassified, whatever. Are we together now? Now, so what's the issue again? Hello, talk now. Talk. We have a grace of like next 5 minutes we should be done. Yeah, it's almost past 5. We came late now. Out together now. So we can do the same for natural. For natural, you can repeat the same. Josh. Selection. Select by location. My natural. No. This is what I did. Check what I did. Stop what you are doing. Once you go to the symbology for this road, right? Come to categories. Your value field should be typed. That is where you are getting it wrong. OSM lo mu type lo ma mu to ba so mu type, you uncheck this and then you add all values, then you now click OK. Yeah, so that's what we have. Are we together? Yeah. So you click OK. Yeah. So now, so go to the selection, select by location, click on natural. It's because Benga is disturbing you, Abi. Femi, are you the one disturbing him? Okay. Click on your natural. Rainbow. It's a line. Yeah, of course. You clip. Your waterways is a line. You clip. All together. Now, OAU boundary are completely within the whatever. So you click OK. You can see now. No, we're trying to perform query for natural. Yeah. Add your natural. Man? Rivers, streamlines. Man? Vegetations, forests, dam, ponds, whatever, and so on and so forth. You get that? Natural. No, don't forget about that one. Don't depend on that. It's by location. The way you did for building, it's not been natural to where you completely within software. Okay, all together. Together. All right. So you can create a new feature from this natural. Remove this, and this is the natural. So your natural too can be symbolized. Yep. By location. The way you did for building. No. The way you did for building. It's not breaking out. Yes. Are you sure you have natural within your study area? Why is it natural features? I didn't ask you to clip. Selection by location. Should have it now. Let me see. So now, hello, Raphael, Antonia, and clip. You're going to change this. I prefer using this lake. I prefer using this type of color for my water. Yeah, lake. So my forest is green already. So click OK, and then I have it. So you can see the dam. The dam is like this, and then the forest and blah 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 like that. So okay. Yeah. Type. I can't say that because we downloaded the special data. It's not like we created it. We downloaded it. So that is the available data they give to us. So I can't have question why we have a small. No. It's not like it's not like it is. It's not capturing everything. So you can digitize more on your own side. You get that? But yeah, so you can digitize more, yeah, on your side. So like that. So I think I just have to summarize it here and call it a day because it's almost. So we'll do that next week. We can't do control today because we have to go to USGS site, downloading the digitalization model, generating the random sample points, interpolation, IDW or region, and then we can have our contours. It's a long process. Yeah, you can use global mapper. If you're using global mapper, it's still the same. You're using the same source. It's SRTM, right? So it's still the same source. But I prefer interpolation. I'll create points of my choice, like spot height. I will now extract the elevation to that point. Are we together? I will not generate a new contour. That's how I prepare my own contour. We did that for Ife Central last session. You do recall? No, it's not an app. It's like a website. That's where you download your Landsat data. Do you know USGS, Earth Explorer? Yeah, they have SRTM. They have SRTM. So once we get there, you understand it better. I understand the concept of using Global Mapper too. We have a GDN and we have SRTM, so I know it. Yeah. There are even new automated way you can download your game. You can use your Google engine coding. So we still go there too, but let's take it little by little. Man? Again, that'll be next Friday. I sent the link to join. I sent it to your WhatsApp to join next week Friday, 3 to 5. So we can all say about drawing. I think that's all for today. So we are able to, at least we are able to get some spatial data, and we imported it then into the Arcmap environment for visualization to have a digital map. We are unable to generate the map itself, having mapped elements like your true north, your scale, and everything. So maybe by next week, yeah, we're done. So maybe by next week, we can add our contours, and we can now print it out in the form of a map, and so on and so forth. So, thank you so much. I'm good, bro. You're welcome. Make sure you save your drawing, oh. Make sure you save it, oh. Please, let's close the windows, oh. You're done. So continue next week.